a sphere of radius r is cut from a larger solid sphere of radius 2r as shown in the figure. The ratio of the moment of inertia of the smaller sphere to that of the rest part of the sphere about the y-axis is. So, here is a sphere of radius 2r and a smaller sphere of radius r is cut from the larger sphere. We have to find the moment of inertia of the smaller sphere with respect to the remaining part of the sphere. Now, let's assume the total mass of the sphere is capital M. So, when the sphere is not, the sphere of radius r is not removed, the total mass is M. So, the total moment of inertia about the y-axis is I is equal to 2 by 5 m r square, that is the radius. Now, radius of the larger sphere is 2r. So, 2r whole square, that is 4r square. So, 4 into 2 8, that is 8 by 5 m r square. This is the moment of inertia of the solid sphere. Now, the moment of inertia, we have to find the moment of inertia of this smaller sphere of radius r about an axis about the diameter parallel to the y-axis. Let's say this is the axis CD. So, first we have to calculate the mass of the smaller sphere. So, the mass of the larger total sphere is m. Now, the density is same, that is mass per unit volume will be same because it is uniform. The density is uniform. So, the total mass divided by total volume, that is 4 by 3 pi 2r cube, 2r whole cube is equal to the mass of the smaller sphere, that is m dash, divided by volume, that is 4 by 3 pi r cube. So, 4 by 3 pi cancels, 4 by 3 pi cancels. So, m dash is equal to m r cube divided by 2r whole cube, that is 8r cube. So, this is m by 8, r cube cancels. So, m dash is m by 8. So, we get the mass of the smaller sphere is m by 8. Now, the moment of inertia I about CD of the smaller sphere is 2 by 5 mass into r square. Mass is m by 8 and r is r square. So, radius is r square. So, 2 by 40 m r square. Now, we have to find the moment of inertia about the y-axis. So, the about y-axis, let's assume the moment of inertia of the smaller sphere is I1 about y-axis. Now, CD and y-axis are parallel. So, we will apply the parallel axis theorem, that is ICD, that is 2 by 5 mr square, 2 by 40, sorry, 2 by 40 mr square. This is, we already get this one, ICD plus mass is m by 8 into the distance between the two axes, that is y-axis and CD, this is r. So, m by 8 r square. So, this becomes 40 is LCM. So, 40 LCM and this is for 2 plus 5, that is 7. So, 7 by 40 m r square. So, the moment of inertia of the smaller sphere about y-axis is 7 by 40 m r square. Now, we have to also find the moment of inertia of the remaining part, that is without the smaller sphere. So, we know the total moment of inertia is I, that is 8 by 5, we already got there. I is the total moment of inertia and the moment of inertia of the smaller sphere about y-axis is I1. So, if we subtract I1 from the total moment of inertia, we will get the moment of inertia of the remaining part, I2. So, I2 is I minus I1. Now, I1, I is 8 by 5 mr square minus 7 by 40 mr square. So this will be equal to, so 40 is LCM, so 5 into 8, that is 64 minus 7. So 64 minus 7 is 57. So 57 by 40, that is 8 by 5 minus 7 by 40, we will get 57 by 40 mr square. So we get the moment of inertia of the remaining part of the sphere is I2, and the moment of inertia of the smaller sphere is I1. So we get I1 and I2. So we have to find the ratio of I1 and I2, that is I1 divided by I2. So I1 smaller sphere, so smaller sphere is I1, that is 7 by 40, 7 by 40 mr square, divided by I2, I2 is 57 by 40, so 57 by 40 mr square, mr square. Now mr square cancels, 40 cancels, this becomes 7 by 57. So 7 by 57, that is 7 is to 57 is the answer, that is option 3 here is the correct answer. Thanks for watching. Please like this video, subscribe my channel and share this video. Thank you.